This is section 3.2 from chapter 3 for Math 63. We didn't do a lecture on section 3.1 because that was actually an activity that we did in the construction lab regarding the Pythagorean theorem. So we're starting with 3.2. This is pertaining to angles. We'll start off with some relatively easy new nomenclature for you so that you can get the lingo down. This is a copy of a protractor, and we're going to be using that a lot to measure angles. Angles are measured in degrees. We don't use the standard units of measure like English or like inches and feet and yards and or any of the metric, centimeters, millimeters. We don't use that sort of thing. We use degrees, and degrees can be further broken down into minutes and seconds. And let me just take a minute to explain what I mean by that. We're all pretty much familiar with this kind of an angle, especially since we just did the Pythagorean theorem, and we'll definitely call this a 90-degree angle. 90 degrees. It's a right angle. And if we were to break this up into its little parts, 90 parts, then each one of these parts would be a single degree. So this would be 1 degree, and then we'd come up another degree, and that would be 2 degrees, and of course this isn't to scale, but on and on and on and on. So this angle here, this angle is broken up into 90 equal parts, and each one of those parts is referred to as a degree. Now, when it gets really important to break it down further is when we're looking at something that's much further away, maybe out in space. What you can see here is that the angle that you have, and I'm just going to redraw that. Let's pretend for a moment that this is 1 degree, that the further out we go, the bigger the opening. So if I'm talking about something like right here, you know, it's the difference between this side and this side is relatively small. But when I get out here, then the difference between the two sides gets larger and larger. And I have to be able to break that up. Well, the standard that's used is that when the degree is broken up, it's broken up into what's called minutes. Minutes. Not like time minutes. These are 1 degree is broken up into 60 minutes. Now you might say, well, jeepers, Kathy, we've got 60 minutes in an hour, so isn't it the same thing? Well, yeah, that's true. The breakdown is the same, but these are degrees, and our time starts with hours. So one degree has 60 minutes in it. And likewise, if we were to break this down, into 60 parts, and then have a real skinny little minute in here, we'll call this one minute, and we use that notation to show minutes. It's like the foot mark, 1 minute. This in turn is broken into 60 parts, and each one of those parts is called a second, just like in time, but it's not time. So this is 60 seconds. And then if we were to redraw one of those seconds, remember there's 60 of them in here, if we redrew one of them, and I can't really do it here, I just don't have the tools, but let's pretend that this is one second. We show that with 2 little dashes on there, just like we do on inches. So conceivably we could have an angle, let's say we can have an angle that looks like this, that is a total of, let's call this 28 degrees, 28 whole degrees, and 35 minutes and 14 seconds. So conceivably you can have that. Now the good news is that we aren't going to be doing this. We're just going to basically be talking in terms of whole degrees for the most part. But I did want you to understand that degrees are broken down into minutes and then in seconds. Now I want you to notice something about this protractor, some important aspects of it. Everybody's, not going to have the same kind of protractor, but this fella right here is going to be a critical point on your protractor, where these 2 hairlines cross. And that is the beginning of your angle. In other words, these angles that I've been drawing here, This point right here is going to be that point right there. And we can either measure from the bottom up to 90 degrees, is up here you can see, or we can measure from the bottom on this side and up. Now notice that the interior numbers, this goes 0, 10, 20, 30, 40, 90, and then 100, and all the way over to 180. But then there are these outside ones, 0 to 90 and 100 over to 180. Well, they're exactly the same thing. It's just a matter of, are you measuring from the right and going this way, or are you measuring from the left and going this way? So pay attention to the numbers that you pull. And as you can see, there's little tick marks on here to help you actually get as close to being accurate as we can. So if you had something that was 35 degrees, you can say, and we were starting here, then there's 10, 20, 30, and you can see this longer tick mark is 5. So that would be 35 degrees, and we would draw a line in there for the angle. Okay, angles of a triangle. Place close attention to the terminology being used. It's probably going to be new to many of you, and you need to understand and remember these new terms related to triangles and how to use them. We'll finish on this one page, and then we'll stop this video and go on to another. The first thing I want to mention to you is the word ray. This is part of a line that has an endpoint at one end, and it continues infinitely far in the opposite direction, and it typically looks something like this. This is kind of exaggerated. It doesn't really have to have that big fat dot on the end, but the big fat dot does indicate that that's the end. Typically it's going to look something like this, and you might put a little point there on the end, and that's referred to as a ray. Think of it as a ray of sunshine on a happy day, and there's the sun. For an angle, lots of times when we want to refer to an angle, we'll use this little symbol. We don't necessarily have to, but if you see that, at least you know what it means. And angles are formed by two rays. So I have this ray here, I have this ray here, and they intersect right at those endpoints. And an angle typically goes infinitely far out in these two directions. And I can refer to this angle in lots of different ways. You can see I put a 1 in here. You might even see a little arc drawn in on some of the diagrams. So I can refer to this as angle 1. I could refer to this as angle B because of this guy right here. And that guy is referred to as the vertex, where those endpoints cross. And this is a side, BA, the ray BA, and this is a side, the ray BC. Okay? All right, so I can refer to this guy here as angle 1. I can refer to him as angle B. I can refer to him as angle ABC, or I can refer to him as angle CBA. The thing to make note of is that the B has to be in the middle.